So let's work out an example on projectile motion. Okay, so in this example, we have someone, let's say, a car running, jumping off a cliff. You don't want to try this at home, okay? But yeah, this is just an example. So let's say that the car drives off the cliff at a velocity of 8.5 meters per second, okay? And let's say that the height of this cliff is 0.61 meters, okay? Now, in solving projectile projectile motion problems, what I ask students is to, when especially you're starting these problems, a good idea is to make a table of your knowns and unknowns in the x and y direction. Okay, so once you get used to these problems, you won't need it, but in the beginning, make sure you do that. Okay, so you can make a table of known in x and known in y, so that you train yourself to think about the two directions independently. So in the x direction, what do you know? You can pause the video and think about it. What do you know in the x and the y direction? So in the y direction, we know that the initial velocity is 0. There is no velocity, there is no vertical velocity in the y direction. The cliff is horizontal. When the car leaves the cliff, it only has this horizontal component. So v naught x is 8.5 meters per second. What else do we know? We obviously know what is true for projectile motion. When the car leaves the cliff, it's a projectile, it has 0 acceleration in the horizontal direction, and its vertical acceleration is negative g, which is negative 9.8 meters per second. And we know delta y. So now you can take this as your y equals 0. Okay, so your delta y is going to be negative, right? So if this is your y equals 0, then your y equals your y final is 0, your y initial is this. So y initial is 0.61 meters. So final delta y is y final minus y initial, so you get negative 0.61 meters. So now we have all the knowns and the unknowns. And what happens in a lot of these problems is that you will now remember, the easy thing about the x direction is that so what let's first see what we need to find in this problem. So we need to find this distance, okay, this horizontal distance that the car covers as it falls off the cliff and reaches the ground. So we need to know this, we need to find this delta x. That's what we have to find, okay? So delta x is the unknown. So you can write that unknown is delta x, okay? Now, there's only one equation. Remember, for the x direction, there's only one equation that's useful, right? We said that ax is 0. This gives you that delta x equals v naught x times t. So that's the only equation. So the question is, do we know v naught x? No, we don't know v naught x. Oh, sorry, we know v naught x, but we don't know time. Okay, so we know v naught x, that's 8.5 meters per second, but we don't know time. So we need this, so we need time. And time is the common variable between the two, right? So this is a very common strategy that you will use. You will get time from one of the axes and plug it into the other, right? So in this problem you can use time. You can use the y equations to get time and then plug it into the x equation. So let's see which equation we use in the y direction. So we know that now we need time. We know that delta y is equal to v naught y t minus half g t squared. That's one of the equations, right? So if you're doing it for the first time, what I tell students to do is to circle the variables you don't know in the equation, and so we don't know time, right? We know you can check mark what you know. We know this. We know that initial velocity is 0 in the y direction, and we know g. So if there's only one circle at time only one. So there's only one circle, and you can use that equation. Okay. So you can write. So there are only three equations. You can write them and check mark what you know, circle what you don't know. If there are two circles, you cannot use that. You cannot use that equation. If there's one circle, you can use that equation. So we can use this equation, and this just gives us delta y equals, since this is 0, negative half g t squared. So you get t squared equals negative 2 delta y over g. So that's like negative 2 times 0.61 meters divided by 9.8 meters per second squared. So if you plug in the time and take the square root, you get 0.35 seconds. So that's your time. So that's the time that the car takes to cover this vertical distance. Okay, and during the same time it covers this horizontal distance delta x. Okay, so now the only thing we need to know, now we know the time, so we can just use this equation. So delta x equals v naught xt, and v naught x is 8.5 meters per second, and that's multiplied by 0.35 seconds. So you get 3 meters. Okay, so delta x is 3 meters. Okay, so this was a relatively simple example. You can have the car, you can have a situation where the cliff is, for example, at an angle, and the car leaves at an angle. So then that makes things tricky. Then it has both a vertical and a horizontal component of velocity. So we will solve more problems later in later videos. This was just first an example, projectile motion. But make sure you do this if you're doing again, I will emphasize that if you are doing this for the first time, make a table of what you know in the x and y, and write down the equations and tick mark what you know, circle what you don't know to figure out which equation to use. Okay, that's a strategy that will help. Okay, thank you for watching. If you have any questions, post them in the comments, and please subscribe. Thank you. Bye.